All right, so video is going to go over pages 32 and 33 in your packet. Shouldn't take very long. So we're dealing with the universal law of gravitation assignment. So it says find the force of attraction. So we're looking for force between two lead balls that have a mass of 5.9 kilograms. So there's mass 1. And our second one is 0.047 kilograms. So there's mass 2. That centers are separated by 0.055 meters. So there is your distance. Okay, so we're going to use that equation. So remember that F equals big G times mass 1 times mass 2 all over d squared. Okay, so we're just going to plug in. So remember that big G is that 6.67 times 10 to the negative 11. Okay, times mass 1, which is 5.9, times mass 2, which is 0.047, all over our distance squared, so 0.055 squared. Just be careful with your calculator and don't forget your squared on the bottom. And you should get 6.11 times 10 to the negative 9 newtons. And that would be your answer there. 2, what force of attraction? So we're looking for force again. Does Sally, 50 kilograms, so there's M1, and Tom, 70 kilograms, have if they're on 20 meters apart on the dance floor? Okay, so there's your distance. Okay, so we're going to find our force. So force equals our big G, 6.67 times 10 to the negative 11. Times mass 1, which is 50, times mass 2, which is 70, and our distance, which is 20 squared. So that's going to be 5.83 times 10 to the negative 10 newtons. Okay, so that means even though it's small, there is some natural force of attraction between Sally and Tom. Okay, now when it says what force of attraction does Tom have on Sally at the same time, once you know this force, okay, that is the force of attraction. That doesn't mean that Tom has some stronger force or Sally has a stronger force. Is once you know that attraction, that force of attraction, that is the same attraction force. So that is your answer for B. Okay, so it doesn't change. Number 3, 2 bowling balls are of 6.8 kilograms. So that's both mass 1 and mass 2. Are 21.8 centimeters apart. So you just got to watch out for this. Can't have centimeters. So divide by 100. Okay, because there's 100 centimeters in meters, so that's 0.218 meters. There's your distance. What is the force of attraction? So you're looking for F. So F equals our big G, 6.67 times 10 to the negative 11, times mass 1, 6.8. Uh-oh. There we go. Times 6.8 again. All over our distance squared, so 0.218 squared. And you're going to get a force of 6.49 times 10 to the negative 8 newtons. Okay, so we're going to move on to the next one. So the force between two objects is 7 times 10 to the negative 10 newtons. So there's our F. When they are 5 meters apart, so there's your distance. If one object has a mass of 10 kilograms, so we'll just say it's mass 1. That means we're looking for mass 2. Okay, so we're going to plug in. So 7 times 10 to the negative 10 equals big G, 6.67 times 10 to the negative 11, times mass 1, which is 10. Mass 2 we don't know. I'm going to leave it as M2. You can put it as X if you want to. And then your distance is 5 squared. Okay, so mathematically what you're doing is you're looking for M2. So what I would do, the first step I would do is I would multiply both sides by 25, which is 5 squared, to get that off the bottom. And then what I would do is you can do it two ways, is you can divide both sides by 6.67 times 10 to the 11 and then divide it again by 10, and there's your mass 2. Or you can go ahead and multiply 6.67 times 10 to the negative 11 times 10 and then divide both sides by whatever that is. Regardless, you should get a mass 2 of 26.24 kilograms. And there's your answer there. Okay, so now we're going back to relationship stuff. So remember, if mass goes up, force goes up, it's direct. And if distance goes up, remember distance squared. Okay, if distance goes up, force has to go down. Okay, so what we're going to do is we're going to do the opposite squared. Okay, so it says what happens to the gravitational force between two objects when the distance between the object doubles? Okay, so d squared goes up, so multiply by 2. Okay, that means force has to go down. So opposite would be divide by 2, but you're going to divide by 2 squared. Okay, so you're going to reduce by a fourth. Okay, so force will go down by a fourth. So that's basically what you're looking for there. You can write it any way you want to. You can write force equals 1/4, whatever, as long as you get that same kind of thing. Now, if my distance triples, okay, so now my distance is going to go up by 3. So force is going to go down. So divide by 3, but square it. So now my force is going to go down by a factor of 9. Okay, so or you can write 1/9 of whatever you were. Now my distance is cut in half. Okay, so d squared is going down, divide by 2. That means force has to go up, so opposite would be multiplied by 2, but I'm going to do this 2 squared. So that means your force is going to go up by a factor of 4. It is cut to 1/3. Okay, so now d squared is going down by dividing by 3. So force is going to go up. Opposite would be multiplied by 3, but 3 squared. So that means force is going to go up by a factor of 9. And last one is cut to 1/4. So d squared is going to go down by dividing by 4. So that means force is going to go up by doing the opposite. So instead of dividing by 4, multiply by 4, but 4 squared. So that means your force is going to go up by a factor of 16. And there's it. Okay, number 6 is what is the distance? So you're looking for distance between two masses, 300 kilograms and 200 kilograms. So there's M1, there's M2. They have a force of attraction of 0.000085 newtons. There's your F. Okay, so we're going to plug in. So 0.000085 equals big G, 6.67 times 10 to the negative 11 times mass 1, which is 300, times mass 2, which is 200, all over d squared. Okay, so remember, if you have a variable on bottom, you can do this trick right here. You can switch those two. So d squared equals all that divided by 0.000085. Now, just don't forget that when you do that, you're going to get an answer that's going to be equal to d squared. So don't forget to square root at the end to make sure you're going to figure out what is distance, not distance squared, but what's just distance. And you should get d equals 0.22 meters. And that'll end that one.